My dear children, today I am going to explain you the iodometric titrations. What do you call? Iodometric titrations for the calculations. Right? It is very important because in MCQ questions as well as in essay paper inorganic questions, most of the questions are based on iodometric titrations, right? Today I am going to explain in detail how we use the iodometric titrations for the practicals and for the calculations, right? Then, what is the iodometric titration? What do you mean by the name iodometric? Iodo means iodine. So if we consider an aqueous solution, it has I2, dissolved I2. This solution has dissolved I2. So we are going to determine the amount of I2, number of mole of I2 present in this solution. For this determination, we are using a titration to determine the amount of I2, number of moles of I2. We are used a titration method. Titration. It is the iodometric titration, right? Then we can known volume about the volume V cubic centimeters. Now we are going to determine the amount of I2 in this solution. So for the titration, we have to take as the other reactant the burette. It should be filled with standard solution of sodium thiosulfate Na2S2O3, aqueous solution. Standard means known concentration. If we take as 1 m standard sodium thiosulfate solution as the solvent in the solution in the burette, going to titrate against with this solution. So this is the volume of the taken volume V. It has I2. Burette is filled with 1 m sodium thiosulfate aqueous solution, right? Then we must know what is the reaction is occurred when we are adding sodium thiosulfate from the burette into the titration flask. The iodine is present in the titration flask. Then thiosulfate reacts with iodine. Then we must know that how they react to each other. Na2S2O3 ionizes. It is completely ionized because sodium is an active metal. 2Na plus S2O3 2 minus thiosulfate ions. So this solution supplies thiosulfate ions to react with I2. Thiosulfate S2O3 2 minus undergoes oxidation, forming S4O6 2 minus tetrathionate. Thiosulfate oxidizes to S2O3 oxidizes to S4O6 during the reaction. So is it an oxidation? We can find out. What is the oxidation state of here? Sulfur. 2x minus 6 equals minus 2, x equals plus 2. Sulfur is at the plus 2 state, oxidation state. Here 4x minus 12 equals minus 2, then 2.5 plus 2.5, oxidation state of sulfur here. So it is an oxidation. Thiosulfate undergoes oxidation. Then I2 should be reduced. I2 undergoes reduction giving I minus. So we can balance this equation. Here 2 minus into 2, we have to balance. 2S2O3 2 minus give S4O6 2 minus. Then we must add 2 electrons to this side. Then here 2I minus I2 plus 2 electrons to this side. This is reduction, this is an oxidation. Then we can add these two equations to find out the total reaction. Then electrons are cancelling. 2S2O3 2 minus plus I2 give S4O6 2 minus plus 2I minus. This is the final reaction. Name as 1. This is the reaction is occurred during the iodometric titration. Here I2, we are adding sodium thiosulfate, then they react to give thiosulfate react with I2, thiosulfate oxidizes, I2 reduces forming S4O6 and 2I minus. Right? So it is clear that if we are able to determine the volume of thiosulfate is required, V1 can be read, then concentration also known. If we know the thiosulfate concentration and volume, we can calculate the number of moles of thiosulfate. If it is N, the number of moles of I2 becomes N over 2. This is the amount of I2 in this solution. So now you are clear that using the iodometric titration, the amount of I2 in an aqueous solution can be determined. Right? Then you have a problem. What is the suitable indicator here? What is the suitable indicator here? You know that I told you last day, for the acid-base reactions, we can use phenolphthalein or methyl orange for the titrations, acid-base titrations. According to the color change, we can take the readings, right? But here, not an acid-base titration. Thiosulfate react with I2. In this case, you know that I2 gives blue color with starch. This is the test to identify starch. Starch gives blue color with I2. I2 gives blue color with starch. Then before the titration, we must add little amount of starch. So the solution becomes blue. Solution becomes blue. Starch has the white color. White colored starch becomes blue colored. It is the initial color. Then you are clear that I2 react with thiosulfate to give I minus. If the reaction gets completed, I2 becomes I minus. At the end point, no I2. All are converted to I minus. Then starch unable to give a blue color, then it becomes white. It becomes white. Then it is clear that to determine the end point, we can use for this titration as the indicator starch. Then we have to add dropwise thiosulfate until the solution becomes blue to white. Right? This is the iodometric titration. Then this equation I write here. This is the required equation for the iodometric titration. Right? 2S2O3 2 minus plus I2 gives S4O6 2 minus plus 2I minus. The reaction 1. The iodometric reaction of the iodometric titration. Right? So now we must know that if an aqueous solution has any amount of I2, we can find out using this titration. Right? Is it clear, my dear children? Right. Then now I am going to explain you how we use this titration for the calculations. How we use this titration for the calculations. Right? Then see here. Today I'll explain you very simple problem was given in the previous calculations problems also. So there is an aqueous solution. Is given. The volume is 100 cubic centimeters. It is if we assume as dilute HCl, then we are going to determine concentration of this solution. Right? HCl ionizes to give H plus and Cl minus. This solution contains Cl minus ions totally because HCl is a strong acid. Then we are going to find out what is the concentration of HCl. To determine. Then it is, I know that you also can be given other titration also. So we can use titration with NaOH, acid-base titration also. But now I am going to explain you how we use iodometric titration to determine the concentration of HCl solution. Right? Because some problems are given like this. Okay. Then to that volume add KiO3. KiO3 can be added solid because it is ionizable solid. So it undergoes K plus IO3 minus dissociation to give Ki also, potassium iodide, solid. It also ionizes to give dissolving K plus and I minus. Now this solution contains IO3 minus ions aqueous and I minus ions aqueous. They are present in the solution. What is the medium? H plus medium. Acidic medium. H plus was supplied by the HCl. Then, now we are going to find out the number of moles of H plus in this solution. If we know the number of moles of H plus, the volume is known, or we can take any volume. So we can calculate the concentration of HCl, the solution. Right? Then we must know how they react to each other. How they react to each other. See here, IO3 minus, IO3 minus, 2IO3 minus to give I2 plus 6 water. I2 plus 6 water. I2 plus 6 water. 2IO3 minus. So it is clear that IO3 minus I is at the plus 5 oxidation state. I2 is 0. So this is a reduction. IO3 minus undergoes reduction to give I2 and water, to give I2. Then I minus, it gives I2. Because I minus, I2, 0 and minus 1. It undergoes oxidation. So it is clear that IO3 minus undergoes reduction to give I2. I minus also undergoes oxidation to give I2. Both are given I2 to the solution. They react in an acidic medium. So when we balance the equations, I2 plus 6 water, here 12H plus 10 electrons. Is it clear? 12H plus 10 electrons, 2IO3 minus give I2 plus water. Then 2I minus I2 plus 2 electrons here. This is oxidation, this is a reduction. Then we can add these two equations, multiply by 5 to be cancelling out the electrons, 10 electrons, it becomes 12H plus 2IO3 minus plus 10I minus to give 516I2 plus 6 water. The final equation will name as 2. The reaction is occurred after the addition of KiO3 and Ki in solid form to the HCl solution. Right? Now, in the HCl solution, what are the products? That solution now contains I2 plus water. I2 plus water. In this case, we have to add sufficient amount of KiO3 minus and Ki. Right? So this is the complete reaction. Is occurred when HCl reacts with KiO3 and Ki. IO3 minus I minus both are given I2. The H plus converted to water. So see here, according to this equation, you are clear that if we are able to determine the number of moles of I2, in this solution was formed, we can calculate the number of moles of H plus. This is the relation. If we know the number of moles of I2, so we can calculate the number of moles of H plus here. Right? It is the required equation, second equation. Is occurred in this solution. Then, if we know the volume, it was given as 100, then it has I2 and I2 due to the completion of these two reactions, right? Then how we find out that I2? If you know the amount of I2, it is possible to calculate H plus, number of moles of H plus in this solution. So we can calculate the concentration of this solution, right? Then what should be done? This solution completely of 25 sample we can titrate. After that we can titrate with sodium thiosulfate. The solution was taken from this mother solution. We can take 25 cubic centimeter. This is the standard 1 m solution of sodium thiosulfate. Then concentration is known. This is the taken volume of this solution. It has I2 so formed. Then we apply the starch as the indicator. Then we can titrate, or we can conduct the titration with thiosulfate and I2 solution. Now, during the titration, this is the reaction should be occurred. Now this is the iodometric titration. Then we can read the volume of thiosulfate required. If we assume as 20 cubic centimeter, then the reading should be taken. Then, now we can calculate the number of moles of thiosulfate used here. Concentration is 1 into volume 20 divided by 1000. This is the number of mole of thiosulfate. Then I2, number of moles of I2 should be 2:1, half of this. 1 into 20 divided by 1000 into 2. 0, 0 cancelling, 2, 2 cancelling, 0.01 mole. The number of moles of I2 was formed in this solution in 25 cubic centimeter volume. We have taken 100, no problem. Then we can calculate I2, number of moles of I2, 0.01. Then that I2 amount was formed in this solution 6I2 12H plus. This is the relation between I2 and H plus during the previous reaction of this solution. If we know the number of moles of I2 0.01, what is the number of moles of H plus? 6 into 12 means 1:2. Then the number of moles of H plus 0.02 mole. Right? This is the number of moles of H plus was formed in this solution. How much? 25 cubic centimeter. Not 100, 25 was taken. So now it is clear that we can calculate the H plus concentration. Number of mole 0.02 is present in 25. Then how much in 1000? 25 contains that amount of H plus. Then how much in 1000? So it is clear that 40, so 0.8 mole per cubic decimeter. This is the concentration of the previous solution of HCl. So we had used the iodometric titration to determine the H plus concentration. It is one example. So there are so many similar reactions. Now you can understand that because iodine, there are so many reactions. By these reactions, I2 can be formed. I2 can be produced. To produce I2, I minus should be oxidized. Then another one should be reduced. Then there are so many ions, different calculations. So underwent reductions. Then now you are clear that you can think about that. Except H plus also, if any ion is present here, we can calculate the number of moles of that ion if we determine the number of moles of I2 supplying iron acidic medium. Right? This is the method of using of titration. What do you call what type of titration? Iodometric titration. And this is an example using the iodometric titration. Such type of examples for the problems can be given. Right? So it is very important. You must think about again and again. These are very common problems in your exam. Right? In other hand, it is very easy after the understanding. Right? Then, today I want to tell you, my dear children, now, after that, I will be doing revision classes also 2016. After the results will be out, right? As soon as I will start the revision classes for the 2016 revision. Okay? Then anyone, in other hand, 2017 classes also, I had started, then I will be started in future. After New Year, so the so many classes will be started. The most of the children are waiting for to be attended these classes after the New Year. Right? Thank you so much for all of you, and I wish you Happy New Year. Then After the new year, we will meet again during such type of calculations, right? Then you can contact me for your any type of classes, right? 2016 revision classes, 2017 theory classes, or individual classes also. You can find out my number and you can contact me very easily. Thanks, my dear children. See you again. Right.